Alright, in this second concept video we're going to develop some formulas that can link polar and rectangular coordinates together. So the first one we're going to do is going to be polar to rectangular. So let me give you a point here, and we'll just make this point right out there. And what we're going to do is we've got an R here and a theta there, and then in a different color here we'll do x and y. So we're basically just forming a right triangle here. So this distance is x and this distance is y. So if we're given a point that's in polar, so we have the stuff in orange and we want to get the stuff in blue here, the rectangular, what we need to do is somehow have a way of linking r and theta and x. If we ignore y for right now, we can do this because we know some of our trigonometric ratios that can work here. So if we look at x, x in terms of this angle is the adjacent side, and then the r is going to be the hypotenuse. So we've got adjacent hypotenuse, that is cosine. So what we can do is we could write a little equation here. The cosine of theta is equal to x over r. We want to solve for x. We want to get x by itself, so we could multiply by r here. Those would cancel, or at least become 1. And then we're left with x equal to r cosine theta. So this just uses some trigonometry, and we can now take any polar point and find the x coordinate in rectangular. So we're transitioning from polar to rectangular. You might ask yourself, does this work for y? It does, except now we've got the opposite and the hypotenuse. So what we need to do is use a different trigonometric function, and that of course is sine. So we're going to have sine of theta is equal to y over r. If we multiply by r on each side, we've got y being equal to r sine theta. And those are the two formulas that we need to take any r and theta. Of course, that would be polar, and then we can find our x and y. And so when we write that down, our x and y will just go in a regular old coordinate pair. We'll do the same thing here for rectangular to polar, and I'll draw the same sort of setup here for you. But this time we're going to go a different direction. This time we're going to have x and y, and we're going to need to find r, and we're going to need to find theta. So maybe I'll use a different color here, slightly different. We'll just do some purple. So we still have x, and we still have y, and that still describes that point. So what we need to do is we need to somehow find a way of linking, and I forgot to write the r in there, we need to find a way of linking x and y to theta, and then x and y to r. So let's do x, y, and r to begin with. If you note, those are just three sides of a right triangle. So what we can do is we can set up the Pythagorean theorem, x squared plus y squared equals r squared. We could square root each side, and you'll note that r could be the square root of x squared plus y squared. So now if you're given the x and y, you have the rectangular. To get the polar, at least the radius, you just square root x squared plus y squared. The next thing we need to do is find theta. So if we ignore the r part here, we're looking at theta, y, and x. We can tell that we have theta, and then we have the opposite and adjacent side. So this is going to be the tangent. So what we'll do here is on this side we'll do the tangent of theta equals y over x. And so this will be the inverse tangent of theta, or the inverse tangent will be y over x. And these are the two formulas you want to remember here and here. And then you also want to remember x is equal to r cosine theta, and then y is equal to r sine theta. These are the important ones.